Welcome to video clip 5.5, in which we discuss object lifecycle conformance. If we look at process model, it appears to be well designed, and from the structure it's well designed. If we do a soundness check, it is also sound in this case. But we look at the labels that are associated to data, as we've seen earlier this week, we might encounter a problem in this case. So let's look at this process where a reseller has the event order received. It's the start event of this process. And the receipt is confirmed. So confirm order means always I confirm the receipt of this order. Then we have a decision to reject the order, or in the other case, when we accept the order, we have two concurrent branches, create the invoice, and send the order and pack the order. Then we receive the invoice and we archive the order at the end of the day. So when I explain this to you, probably you have noticed already that there is a there is a wrong ordering of the activities. Here we have the sending of the order before the packing of the order. That's wrong, and also there is no activity dedicated to checking whether I want to reject or to accept the order. So the correct process model would look like this. And in this video we will discuss how we can use object lifecycle, so the state and state changes of data objects, to detect these types of errors in process models. So here we have the check order activity that is embedded here, and then we have, of course, the packing of the order before the sending of the order. So data objects change their state during process execution. We've seen that already before. Indeed, these state changes need to comply to the data object behavior. We know from the object orientation paradigm that objects are represented by structure and behavior, or state and behavior. And the behavior is represented by state changes. And we assume now that we have the data object lifecycle available. So that, and that's often really the case when we have an IT system that is implemented in the organization, and we know which data objects are there, and we also know the states that data objects can take. Well, that is the assumption. And we want to check whether the behavior of the data object or the state changes of the data objects are really in line with what the business process expects from them. All right, so these state changes need to comply to the data object behavior, and this can be specified using data object life cycles that are specified as state transition diagrams. Here we have an example of the object life cycle of the order that we've been looking at before. Here the states of the data object are represented by these ellipses. So first there's an initial state, then by the confirmed transition the data object goes to the confirmed state. Then there is a check activity, two check transitions are there. So after the check, either the order is rejected or accepted. If it is accepted, it can be packed and sent and archived. And if it is rejected, it is immediately archived. So that's the representation of the behavior of the data object order. Now we can try to find inconsistencies between these two models. We have two models here. That is the object lifecycle, and that is the process model. And we can try to detect inconsistencies between these two, and we can do that even automatically. All right, so of course in the lower part you see the wrong process diagram that opened this video clip, and we can try to find now these problems. So first the data object is in the initial state, then the receipt is confirmed, so we have this confirm, yes, that works nicely. But then we have a check activity here, so then only a check activity can be performed, and we do not see this check activity in the process model. So here we have the first problem, that some check activity needs to be executed here. The second activity is that the order goes from the accepted, assuming the check activity was there, from the accepted state to the packed state, and then to the sent state. And of course, we could use that to find the problem here in this process diagram, that we first send the order and then only later start packing the order. So this is the types of inconsistencies we are looking at now. So the idea of object lifecycle conformance is to define a property for checking consistency between data objects and processes. And we use the labels of activities, and if it is available, we also use the data object and the states in data objects that are read and written by the process. We define as follows: the process conforms to a data object lifecycle if the process includes only state transitions which are defined by the data object lifecycle. So if we have a process, let's choose the pen with a black ink color, and we have, let's say, two activities, and we have a data object D that is in state whatever, A and B. Here it's in state A, so it's read in state A, it is written in state B, and that is input to the next one. Then we have a state change from A, and that is now the object lifecycle of the data object D. There needs to be a state change from A to B. If we have this state transition in the object lifecycle, perfect. If we do not have that, if there is something like this, there is the A, and first we need to go to C and only then to B, then we have an error. And then we obviously, we need to, that's not possible, there's no activity that can immediately change the state from A to B. First we need to do an activity from A to B and then from B to C, so we would be able to detect this inconsistency here. In more detail, process P fulfills object lifecycle conformance for a data object O if the following holds. 1. For each state transition of object O in process P by some process activity, there exists a corresponding state transition in the object lifecycle of O. And also we need to take into account initial state and final state, both in the process and in the object lifecycle. All right, we now have a number of examples, or actually 3 examples, using 3 different object lifecycles. So we have different scenarios, so the object lifecycle changes. The process model is the one we see here in the lower part. Let's check if this process, let's say, complies to the object lifecycle. And here, let's see, we have confirmed order. Yes, we have here the confirm. Then we have the check, yes, state transition to check. And then we have a state accepted. And in state accepted, there can be state change to packed. So pack can use the data object in state accepted, changes it to state packed. So pack is here, then send is here, and send is here. So the data object can traverse from packed to send, and finally it's archived. And there's something intermediary with an invoice, and we do not cover the invoice here. We just look at each data object at a time. And also the alternative, what is the alternative? So we could also reject the order. So there is something we do with the order, namely to reject the order. And if we look at the object lifecycle, there's no alternative, there's no behavior in the object for rejecting it. Therefore, we see a problem here. We expect behavior of the data object in the process model, and that is not provided by the object behavior. Therefore, object lifecycle conformance is not fulfilled. The state transition reject of data object order is or cannot be found in the object lifecycle. Therefore, there is a problem either with the object lifecycle or with the process model, and then experts need to look into this. In our example, obviously, we also need to be able to reject an order. Therefore, the problem is apparently in the order lifecycle. Example 2, here we have the original object lifecycle we've seen before, and here we immediately see that we can have all state transitions that are, let's say, used by the process are also possible in the object lifecycle of the order data object. Here, confirm, check, so confirm, check, pack, send, archive, pack, send, archive. But also it is possible after the check activity to go to the reject case. So here we have the reject order, and after rejecting I can archive the order. Therefore, also in this case everything would be correct. We could also do that with explicit representation of data objects. So I can add a data object here. So the data object order in state rejected. Draw it a bit larger so that we can all see it quite nicely. Sorry, I again need to choose the right ink for that. So we have the data object, and that is the order. Anyway, order data object. Can't I do that? So order, anyway, I hope you can read it. And the order is in state rejected. And that is an outcome, is in the output set. It's one output set of the check order activity. And that is now used as input for the reject activity, right? And the reject activity, from there I could go then to the archive. So that is an example that shows that actually object lifecycle conformance is met here. I need to erase that again so that we can also see the text here. Object lifecycle conformance is obviously fulfilled because all state transitions can also be found in the object lifecycle of the data object order. Object lifecycle 3, here we see an extended lifecycle that also has this not decided place. Here we see the not decided state in the middle. And it just says after checking, we can either accept or reject it, but we can also have this not decided to do additional checks so that we can later either accept it or reject it. So let's look at the process again. And also here, all state transitions that are used by the process model are represented in the object lifecycle, yes. But there is more. There's this not decided state that is not used. But we did not ask for a one-to-one correspondence between process and data object, but we just said everything that the process requires in terms of state transition is provided by the object. And that obviously also in this case is true. So object lifecycle conformance is fulfilled. Also in this case, the process requires only allowed state transitions. Other processes may require the additional behavior of the data object. So this additional data object might be required by other processes that do whatever additional checks once that is not decided. And the idea is, of course, that data objects are not attached to only one business process, but they can be used by many different business processes. Usage scenarios of this technique is twofold at least. So with the help of object lifecycle conformance, the modeling errors and inconsistencies between process and data can be detected. In the process model, there might be missing or wrong activities or even wrong sequences of activities. Our initial example showed this case. But also we might be able to find inconsistencies or errors in the data object. So the data object lifecycle might also contain errors, and we might be able to detect these errors looking at the process. And also extension of operational business processes for developing implemented process models. Also these scenarios are very useful because you also regarding implementation, you are sure that the data objects can, let's say, be used to implement the process as we have defined it. That brings us to the end of video clip 5.5, in which we discussed object lifecycle conformance. Processes and data object lifecycle must be consistent. We discussed that. Object lifecycle conformance requires that no new states or state transitions are introduced by the process model that the data object cannot fulfill. However, not all states and not all state transitions need to be visited by business processes. And that is due to the fact that objects might have a richer behavior and not all of them might be required by a given business process. This short video summarizes week 5. In week 5, we looked at data and processes. We started with a high-level view of organizing business processes. We saw that there is a supplier-customer relationship between business processes, both on the level of organizational business processes as well on the level of the operational business processes. We looked at how to represent data objects in bpmn, not only data objects but also states of data objects and data flow. We looked at data object collections and the role of multiple instances activities. We learned that data has impact on the execution semantics of the process, so that a given activity can only be enabled if not only the sequence flow is signaled, but also the data objects that are required are available and in the right state. As indicated before, so we looked at multiple instances activities that are able to process data object collections one at a time, but we can also use single instance activities to process data object collections. And this week closed with object lifecycle conformance, in which we made sure that the behavior of the process and the behavior of the data object match.